All right. Welcome back. Welcome back. Welcome back. This is part two of bash scripting. This is part two of bash scripting. Part two of bash scripting, which is more detailed. Which is more detailed because I'm gonna look at advanced features, especially the granting of permissions on files using what we call the octal system. So I will do that. Okay, in a few minutes, I'll show you how do we allocate, how do we assign permission to files. When you talk about permission, you're talking about the read, the write, and the execute permissions onto the what, onto the onto the files, or even onto the directories. So yeah, we are still in Linux. Okay, we're still in Linux, so it's getting a little bit deeper and deeper, but not that complicated or yeah, or difficult. But I'm just trying to show you how to do some things, or some of the hacks. Can I say that some of the hacks, instead of remembering some of those long commands, you can just use some of there's a simple hack I'm going to show you today, especially when allocating permissions on files. But basically this is still bash scripting. So now we are going to work with what? We are going to work with the terminal to create a bash file. Then after creating a bash file, we have to save the bash file. After saving the bash file, then we need to read the file contents. Okay, we have to read the file contents. So then in that process, that's where we're going to talk about the file system. We're going to talk about the file system in that process. So I'll introduce, then I'll get deeper later on with the file system permissions. But for now, I'm just showing you how to create a bash file, how to create permission on the bash file which I've created. Then later on during this presentation, I will deal with what? I will deal with file permissions, dealing with the octal system. Okay, so sit back, relax. This is TG. I'm your presenter. All right. So, okay. I'm now sharing my screen, sharing the entire screen so that you see the softwares which I'm using. All right, so I'm going back to my what, to my core calc. Okay, so core calc. Right, let me see if I'm able to share this on the YouTube live. I'm not sure if I'm able to share this, to share the link. Okay, no problem. But it's just easy. You just go on Google and you type, or you prompt online online Linux simulators or virtual machines. Then you come across this one, COCALC.com, projects, blah blah blah. Then that's when you come across this terminal. It's quite handy. It's quite good. It's quite handy. I've been using this. It's quite handy. It's quite good. So that's the terminal I'm using. I just fell in love with this terminal. I just discovered it yesterday. With the previous times I was using another one which was giving some problems. Why? Because it was only giving me 1 hour. Then after that it will cut. Then I need to use maybe only 2 hours per day. Then after that it will kick me out. But this one, it goes. You go until you are tired. Okay, so just a recap of what we did. In the first session about directories. We need to know which directories are installed in this machine. In this case, we go back. We've got our documents, our downloads. Then there's a file, my script, students, tutorials, etc. So these have been installed on the machine. Right. Then want to see which from these are files, or which from on these are what are directories. The ls again, ls, then the specifier dash capital letter F. Okay, there we go. then we see that, okay, some of them are full, are what are directories, documents, downloads. Then the one of them is what? One of them is a what? It's a file. MySQL.sh is a file. Okay. Then we want to have a look at hidden files. Some of these files are hidden, some of them are hidden, some of them are hidden. So we want to have the list of everything, including hidden files. So okay, -f, I don't think we need it for now. Okay, -f, we don't need it for, but we can just okay, let's just save it. Just for, remember, we're just learning. Then we put L now. We want to list everything, all of them. Then we put A so that we're able to see the hidden what? The hidden files. Okay, so there we go. There we go. Now we see everything. Now we see everything. Now we see everything. But what I wanted is not that we have to see everything. What I wanted for us to see is these letters: DRW, XR, blah, 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 blah. What does it explain to us? What is this? What is this? So the first letter, can I get deep this now or later on? Okay, I think I'll talk about this later on. That the first letter is the type. What exactly is this resource? Is it a directory or is it a file? So if it's a D, it means it's a directory. If there's a dash like this, it means it's a file. Are you with me? Like this one is a file, Jupyter2, Bash, whatever. All these others are what? All these others are, even these ones which I created, SH. This is the one I created this file. SH, it's a file. It's not a directory. D is a directory. Then RWX, what does this mean? These are permissions. These are permissions on the resource, on the directory, on the file. R, which means you can write. You can write on the, sorry, R is read. You can read on that. Sorry, R, you can read. W is write. Then X, you can execute. These are permissions. So I was talking about this. These are permissions on what? On file. RWX. Then another one again. Then another combination. So there are three sets. There are three sets of RW. I want to find out if I can have a file with everything. And like this one. What is this? This one is almost like that. Unfortunately, we don't have what? We don't have the D, but then we don't have the, okay. Okay, right. Okay, there we go. Yes, we've got RWX, RWX, three of them. Some we've got some missing some missing parameters, but this one, so it means this one, what is this? This call cow, which means you can read, you can write, execute, read, write, execute. What are these? We are talking of what? We are talking of the users of this laptop, users of this laptop. We've got three categories of users. We've got three categories of users. We've got the main user, we've got the group user, and we've got other users. So that's why we've got three sets of RWX, RWX is three sets. So it means what? We've got what? We have got the read, write, execute. The user can do that. Then the group, anyone in that group can read, write, and execute. Then any other person can also read, write, and execute. So yeah, it's very important. So these are permissions, access into that. Then the number, these are connections, connective. These are connections. Then these are the users. Then this is the size of the file. Then the date. Then the name of the what, and the type. Is it a hidden or it's a what? It's an accessible. So these are just permissions. I'm just passing. I'll get detailed later on as we talk about the octal system. But now we're talking about the bash. Why am I bringing this? Why am I bringing this? Okay, we'll go to clear. Why am I bringing this? Because when you're working with bash files, you need to assign these rights as well to the what? To the bash file. You need to assign these rights to the bash file. We need to assign that this, the user must have the right to what? Must have the right to read, write, and execute. Otherwise, you won't be able to use that file. You won't be able to use that what? You won't be able to use that what? That file. So it's very, very important that you know how to allocate these permissions. Okay. So okay. So let's go back to our what? Let's go back to our ls. to our ls. We want to find out which directory are we going to use, which directory are we going to use. Okay, so let's use students. 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 But at the same time, we want to find out what are the permissions in this directory as well. So we go back to our ls, then our dash f. F, let's leave it now so to avoid congestion. ls, then we have what, l and a, so that at least we know if there's any files cannot access la. Okay, so I forgot the dash. ls, then dash, then a, dot l and a. Okay, there we go. All right. Yeah, I need this, only this 1, 2, 3, 4. I want to find out student. Where is my student? There's my student. Student is a directory. Read, write, and execute. Yes, we are allowed to read, write, and what, and execute. As the user, the groups are, we don't care for now. I want to see these permissions, these 3 permissions, RWX. You are allowed to read, write, and execute in this what? In this directory. So I'm going to use this directory, the student. Why? Because it has got these allowances for me, permissions. So, okay, just clear to go back to the top to avoid messing up the presentation. Okay, there we go. So I'm going to use student. I'm going to use student. Okay, where is the student? ls, that student. There we go. So now cd. It's just a reminder. cd what? cd students. cd students. There we go. I want to work inside students. cd. Now I'm inside students. If you're not sure about you are inside students, remember what I told you in the first session. This is the what? This is the PWD. PWD. Okay, which is the what is the current working what? Current working directory or print working directory. Current working directory or print working directory. Which directory are we working in? Check that. That's we are in students. Okay, we are now in students. So PWD, print working directory. Then let us list what is inside students. Let us print what is inside. There's command.txt, myscript.sh. There's blah blah blah. All those files, they are inside. All those files are inside. Then maybe you can find out the permissions on those files as well. Permissions on those files. ls. What are the permissions? lsl. What are the permissions in all these files? ls. Then you see what do we have? Command is what? Command is what? Is read w, but you can't execute. You see the challenge now. You can't execute. Then the other one, this is what my script. You can read, write, whatever. Okay, so this is not magic. You assign. You do this. You do this what? You do these permissions. You do these permissions. You do these permissions. So we're going to do these permissions on our file, which we're going to what? Which you want to use a bash file. We're going to use this, not this file. We're going to create another file, which we're going to use for demonstration, but you must assign these rights. You must assign these rights. You must assign these what? These rights. You need to assign them. You have to create these rights for yourself. So how do you go about that? How do you go about that? How do we go about that? So we're going to create our bash file. 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 So how do you create our bash file? This is the code or the syntax for creating that. We use this nano. There are so many ways. There are so many ways of creating files, depending with the version of Linux you're using or Unix. Some they use nano, some they use the vim, or VM. So there are so many, but this one, it doesn't take the VM, it only takes the nano. So nano, that's my route to create a bash file, to accept the bash scripts actually. So nano, then let's just say script, nano script.sh. It's very important that you specify that Remember, so you were seeing some text file, but this one is now is it's a bash file. So you specify .sh, .sh, which means it's a what? It's a script file. It's a script file, bash file. It's a bash file. Then you press enter. Check, now we are somewhere else. We are no longer on the terminal like the normal. We are now on the scripting what? On the scripting part of the terminal, whereby we can create scripts. So this is the version of the what? Of the Nano, which we are using 7.2 of the bash, what a bash scripting terminal. Then this is the name of the script.sh. That's the name of the script. So then remember what I said initially. I said I will show you how to first of all initialize. Then you now specify that I'm going to use the bash shell to run this file. To bash shell, you give the instruction that I'm going to use the bash shell to run this file. So you declare that, you specify, you tell the compiler that I'm going to use the bash file. So how do you tell the compiler that? The hashtag first, then the exclamation. That's the shebang. Bash hashtag then that exclamation mark. That's the what? That's the bang. So shebang. It's called the shebang. Some they call it shebang, depending coming from whether you are American or you are using the what? American English, or you're using the British English, or you're using the South African English. It depends. Okay, which English are you using? Though shebang. So hashtag, and that it's called exclamation mark. You are telling the compiler that then is going to use the what? The bin, the binary. Then you specify that it's going to be a bash. So I think inside our root, you saw that there's a what? There's a folder, or there's a root for what? There's a root called bin. So all the bash, whatever bash scripts are going to be compiled. They're going to be stored and compiled through that what? The binaries and the bash and the bash directory which is inside that. Then after that, you don't press enter for this. Now we are now doing scripts. We're no longer pressing enter, but we are now saving. We are now saving everything which we are doing. So it's Control O, Control O. Then you see all these to be written. You see at the bottom, file name to be written, script.sh. If you want help, Control G. If you want to cancel, Control C, MD. If you want to append, whatever. If you want to prepend, backup file, browse. All these are other commands, but you're using the control key now, which means we are no longer working with the terminal where we press enter, but we are now working with this. So that's our file. Then you have to check if your file has been created. So you have to go back to the what? Go back to the terminal to check if the file has been created. You have to go back to the terminal to check if the file has been created. So you have to go back to the terminal. So if you saved Control O, yes, then Control C, then Control X, then save modified buffer. Then you press, then there's yes or no. Then we press what? We press yes to show that we want to save. So depending on the Linux version you're using, it depends. If you want to go back, some they click Control clear shortcut it will go back. But on mine it's not working. I'm not sure what's happening. It's not working. So it depends with whatever, or if you're having the installed terminal on your machine, the executable, it depends. But mine, I'm using Control M to go back. I'm using Control M to go back to the terminal. That's the one which is working. Okay, is going Control M. Then I'm going back. I'm now back on my terminal. Now I want to find if my script has been created, script.sh. So remember, I'm in students. Then ls now I want to check where is my script. There it is. The script has been created. Sh, it has been created. But it's very important that you check if everything is in order. Otherwise, it won't work. You have to check if your script has been created. So my script has been created. Script.sh. Then I have to check on the what the permissions on this script. ls-l permissions. What am I allowed to do? Am I allowed to edit? Am I allowed to read, write, or execute? What am I allowed to do? Then enter. Where is my script.sh? Script.sh, where is it? There it is. There it is. There it is. But now check. It's a file. Then I'm allowed to what? To read, to write, but there's no X, which means I cannot execute. Because that's the order. That's the order. RWX, it means read, write, and execute. X is for so which means I cannot execute this file. So which means I must create execution rights. I must have rights to execute this file. Otherwise, I won't be able to run this file. So what do? I have to go back to the what? I have to go back to the file and create these rights. I have to go back to the file and create these rights. So how do you do that? How do you do that? We use this command, which is called the chmod. The chmod. The chmod. Chmod. The chmod command is the one which will allow us to what? The chmod which will allow us to create the rights for this file. Chmod command. We use this chmod command. So this chmod command, we use it to what? To allow the what? Allow the user to execute. Allow the user to execute. So it's plus sign UX. So it's going to allow the user to what? To execute. Why? Because the execution rights are the ones which are missing here. Execution rights are the ones which are missing. But I can read, I can write, but I can't execute .sh. Script.sh. That's the one which I want to have these permissions. Then enter. Invalid. Which one is not? Which one is not? Which one is not? Which one is not allowed there? Which one is not allowed? Okay. I think it's the .sh. Script.sh. Again to see ls -l. Want to see if I have permissions. Where is our file? Script on our file now. That's the script. Check on our file .sh. Now we are permitted to what? Now we are permitted to read, write, and execute. Use the nano again. Don't forget nano what? Nano. We used our nano script. Yes, it's now going to be run by this bash what? By this bash So we're good to go. Our file is good to use. So what have I taught you in this session? I've taught you how to create a bash file, how to close the codes. Remember, we don't press enter here. You save Control O. Control O. We don't press enter. Control O. Yes, I've saved my what? My script. I've saved my what? I've saved my script. Okay, my script is saved. Then Control what? Control C. Control X. This is happening on my machine only, guys. Then yes, to save everything. Then going back, Control M. I'm going back. Control M. I'm going back. Control M. I'm going back to the terminal. Let me just clear. Let me just clear this stuff. Oh, but still, I need my students. Okay, let me. Oh, but to be okay. Let me just clear so that at least I will. Am I able to scroll back? No. Let me clear so that I'll go back to the top. I'll clear to go back to the top. I'm inside my students. I'm inside the student directory. Okay. Right. My file, is it appearing? My file, is it appearing? I think we saw it already. LS, the file is there. Now we want to run the file. Now we want to run the file because we've created permissions. We can now execute, or we now want to execute the file. We want to see what is in the file. So what do you do? The syntax // that's the syntax of running this. Then we specify the file script dot. You save the file. After saving the file, then you create the permissions on the file. Then you open it again. Then you can edit. Remember, you can read, you can write, you can execute. You can now play around with your what? You can now play around with your file. You can now play around with your file. It's now what? It's now editable. But remember what I said. Bash, it reads line by what? It reads line by line. If in case you want to put something in this file, it has to be line by what? Line. It reads line by line. Okay. It reads line by line. Okay. Last but not least, okay, just playing around with our file. So if you want to go back, the same thing again. Nano scripts.sh. Going back to the file. prints line by what? Line by line. So that's the challenge. So this, I know, let me just delete like normally. I want to design a simple program which will prompt the user to enter your username, password, or what. I think that's where we are going now. That's why we're working with these scripts and what. That's basically how you do this programming for this Linux and whatever. We use scripts. So you want your application, when someone logs in, you want them to say, welcome user, welcome so and so. So you enter username, your password and what. Okay. So which I want you to just to test your creativity, that you need to have a program which will allow the user to enter their name, to their username. You're not going to use one of them. If password is like this, it must open, or else it must say unknown user, something like that. So how do you go up that? I'm just showing the simple part. Echo, remember to type something, echo, right, enter your what? Enter your name, and echo, enter your name. Read name. Then second statement is echo again, echo enter your surname. Enter your surname. Then it's going to read what? It's going to read surname. It's going to read surname. These are variables which I'm declaring. Name, surname, these are variables which I'm declaring. These are variables which I'm declaring with name, surname. Okay. Then echo. The system is going to print what? The system is going to print welcome. Welcome. Second, so and so to the system. Okay, there we go. Remember, we don't press enter, you save. You save. Remember, you must save. After saving, that's Control O. Then so I'll run my script. Remember the dash / at the name of the file. Enter your name. Then I type my name, Tendeka. Then sorry, my machine is freezing. I don't know why. Enter your name. Oh my goodness, what's happening with this Google thing? But at least that's how those systems will say enter your username, then enter your password, then there's this logic now. Logic. If this password is not known from the system, then I'm almost. Oh, what am I going to do now? Okay, there we go. Then basically, I'm running my script from the terminal now. So that's how you work with your terminal in the script. In case you can come across such questions which you want you to work with on this, you have to do it. I think I've done this in the simplest possible manner. Okay, I hope this was clear and this was understood. Then the last part, permissions using the octal system. Using the octal system, permissions using the octal system. Okay, let's see how it works. Permissions using the octal system. Okay, let's go to our ls again. Let's find another file. Or the same file. Okay, maybe the same file. Script, the same file. Okay, so let's save file. Save time. Let's not get into those things. Let's just have more permissions on the same file. Let's have more permissions on the on the users, other users, like the main user, the group and the what? The group and the group and the group and the other user. So remember the R, W, and X. R is for read. Then the other one is for what? I said it's what? R is for read. W is for write. X is for execution. Okay. So every file we've got that format. Every file we've got that format. Not only that. So it's about 3 sets. Every file we've got 3 sets. Every file you've got 3 sets. Every file we've got 3 sets. I don't know how best I can show that. Every file with 3 sets, every file with 3 sets of these permissions. Every with this, then it's called the W, and they've got the what? The execute. Every file with these 3 sets. From here, I'm getting it from here as L. Every file with these 3. You see, these are the 3 sets. These are the 3 the sets. Every file with these 3 sets. 1, 2, 3. 1, 2, 3. So some, you see, they've got only the R. You can permissions can be what? These permissions can be allocated. You can allocate these permissions. You can allocate these permissions. You can do that. Allocate those permissions. So that's what I'm showing you here. That every file you've got, every file or folder you've got that which are ranked in such order. The first rank is what? The first rank is the R. Then the second rank is W. Then the last rank is W. Is what? Every file for these 3. The group user and another user. 3 sets is for the group user and any other user. So these are the 3 sets. These are the 3 sets which we are talking about. These are the 3 sets which we are what? Which we are talking about. That is for the what? Then the other one is for the what? The other is for any other user. It's for any other user. It's for any user. That's why we've got 3 sets. So every file, every directory, you've got that. It's very, very important that you know that it is got that. Okay, I'll come back to this later on. So that's what you're talking about. That's what you're talking about. So now it's very hectic and tedious to remember, like, how do I handle this? Because you need to remember the syntax, like this chmod. Chmod what? Chmod, I want to allocate to the user. I want to allocate to the group. I want to allocate to the what? To the what is the script what? Is the script dot sh. Is the script dot sh. You see now the script dot xh. So this one goes through. Right, but it's very hectic. It's very hectic and tedious. Then you need to check if it has been affected. ls ls what? ls, where is it? Script. There you go. There it is. So which means all of them now, rxw, then this one is r, then there's x, then r, then there's x, which means anyone can execute. Anyone can execute this. Anyone can execute this. Now you have to go again and do the one for what? The one for reading and writing. So it's very, very hectic. It's very, very tedious. So how do you solve this problem? How do you solve this problem? We go back. We use the what? The octal system. We use the octal system. We use the octal. We use the octal system. How does the octal system operate? This R is 4. W is 2. Add these permissions which are allocated. It will just add these numbers. In this case, if the user is allowed to read, write, and execute, it will add all of them. It will add them to what? So maybe this one is there's only R and there's no, and if you say this one is equal to 5, these are the rights. And this maybe here there's a 0 and here there's only 1. So it will take the what? It will take the 1. So these numbers will tell you, will solve your problems. These numbers will solve your problem. These numbers will solve your problems. Why? Because the system will know, due to these allocations, that write is allocated 4. So read is allocated 4, write 2, and execute. But the same command chmod. The same command chmod. Then I will say 7. I will say 7. I'm going back to this table, 777. Let's say in this file, all these are allowed in that, or you want to have full access of everything. So you do that. Okay, 777. Okay, on which file? You specify chmod 777 on which file? Let me see any file which is not like, okay, on what text, on my text.txt, on my text.txt, xt. I want 777 on that file. Then ls, then dash l, then I go back to the file, check where are we now. It has got everything, rxw, rxw is very easy. It's like the advanced, but it's the simplified way of remembering. The advanced, I just want them to maybe to add to write only. You can also reduce the writes. Okay, so chmod ch saying chmod. Then let's go to ls minus l. They can do, which is what? Write. They can only write w, but they can't read, they can't execute. Read, no execution. Read, no execution. So that's how basic. Thank you so much. That's what I wanted to say. I'm not sure if the video came right. It was like freezing, but if it's not coming right, I will redo again the last part. I'll redo the last part again. But so far, so good. It was quite interesting. It was quite interesting, especially working with those numbers. It was quite interesting. So thank you so much. Sit back, relax as I'll come back with more additional material to support this as we continue with this Linux journey. We will do until we now know not everything, but quite a lot about this Linux. Thank you so much. Enjoy the rest of your time and the rest of your day, whatever you're doing. Enjoy yourself, guys. Thank you.